we are going to study the counter design. So before that we need to understand what is counter. Okay. When we go for the regular the word count, we go for the taking numbers, or say for example, count the total number of students means we count one by one and say that the total count is 45. Okay. Similarly, a counter is actually a device, that is, it's actually a group of flip flops. Okay, that is based on, or the group of flip flops where based on the clock pulse. Okay, there is a classification based on that. Based on the clock pulse, we there will be set of changes in the output, and these changes will be equal to, or what are the number of changes that have taken place. Or before that, let us go into an example directly. We have I have already told you an example in the previous videos that about illumination. Okay, during the festival seasons and all, we go for the illuminations. Okay, and during when we go for illumination, we see that we have a set of bulbs, 1 2 2 3 4. Okay, and next 5 6 7 8. Okay, 8 bulbs. For illumination, what we do is, first this 2 get counted, next this will disappear, and other 2 will glow, later this will glow, later this will glow. Similarly, we get a pattern. Okay, this counter also counts the same thing, that is the number of here in the case of illumination, it counts for the number of times that illumination takes place, has happened. Okay, similarly, what we say that a counter is actually a device that is used to count the number of pulses. Okay, it will be clear when we go for the design part, but first of all we need to understand that a digital counter is a set of flip-flops whose states change in response to pulses applied at the input to the counter. Okay, and when based on the clock pulse, we can classify them into two. One is synchronous and other one is asynchronous. Okay, so we need to understand that it's a set of flip-flop whose states change in response to pulses applied at the input to the counter. Okay, the flip-flops are interconnected such that their combined state at any time is the binary equivalent of the total number of pulses that have occurred up to that time. Thus, it's as its name implies, a counter is used to count pulses. Okay, when we go for the design, we will correctly understand how it got that name, that is counter. That is, it's used to, on the fourth pulse, we can understand that the pattern follows a particular the circuit follows a particular pattern, and we understand that during the fourth clock pulse, the fourth illumination has taken place. Likewise, that is, there is a relationship between the clock pulse given and also the what we call the output we derive. Okay, so based on this, we say that counter, the classification is mainly of two types. One is asynchronous counter and one is the synchronous counter, and that will explain right now. And what is the difference means the way the clock is given to the input. Okay, in asynchronous counter, it is not given in a synchronous manner. That is, the clock will be given to the first flip flop from flip flop 1 to 2, then 2 to 3, from 3 to 4. But in the case of synchronous counters, the clock will be given at the same time to all the flip flops. That's the difference. Okay, and I will give the difference right now. And also, in many cases, asynchronous counters, in question papers, the question will be asked as design a ripple counter. When we see that it's ripple counter, go for asynchronous counter design. Okay, please go.